Alright, here we go. Algebra Basics 3, Complex Fractions, and Lowest Common Denominators, or LCDs. So my hope for this one that it's a little shorter and sweeter than Algebra Basics 2, which was quite a lot to get through. So hopefully this will be more relaxing. Our first topic, complex fractions. What is a complex fraction? It's gross. It's a strange beast that I'm not a huge fan of. Most people aren't. And it's hard to see from here, but you basically have a numerator that could be a fraction with a whole number denominator. You could have both be fractions, the numerator and the denominator. Or you could have the reverse and have the denominator be a fraction, the numerator be a whole number. They're hard to look at. You're going to have 3 fraction bars, but this main one, this middle one, is the one that does the math for us. So when we look at them in our class, we're going to have things that look like this. They're usually going to have binomials mixed with with numbers, and it's going to be terrible. But we're going to work our way through them. So numerator in pink, denominator in yellow. So I really want to take that pink and divide it by the yellow. And here's how we're going to do it. First, you're going to break that fraction up. This was the numerator and this was the denominator, and you're going to write it old school with the division sign. Now what you need to remember here, or relearn, is that when you want to divide fractions, like if I had 2/3 and I wanted to divide it by, let's say, 4/5, the first step is flip the second fraction, and only the second fraction. And once you do that, you are allowed to change the sign to multiplication. So looking down here, don't touch the numerator, leave it as is. Flip the second fraction, which was your original denominator, and change the sign to multiplication. So once we do that, we kind of have this thing where we can use the multiplication of fractions rules, which are basically top times top, bottom times bottom. So if we looked at our old number one here, if I wanted to combine those two fractions, and don't mix this up with cross multiplication, the two tops multiply. So 2 times 5 multiplied by 3 times 4 gives you 10/12, which you can reduce to 5/6. But more importantly, let's look at the ones we have here. So I've got my first fraction, and I'm just writing them down. You could rearrange them if you like. Everything that was in the 2 numerators goes on top. Everything that was in the 2 denominators goes on the bottom. And you can combine those all and reduce. I'm going to be lazy because I see some things that are awesome. I see the number 7 and the number 14. So I can reduce 14/7 to 2/1. I see the number 3 and the number 12. 12/3 is the same as 4/1. And all I'm doing there is dividing both numbers by 3. And finally, I see x plus 5 to the power of 8 over x plus 5 to the power of 6. So I can use my exponent laws to do 8 minus 6 and get x plus 5 to the power of 2, or you can just do canceling 8 minus 6, 2 here. So essentially, this whole thing has disappeared. And we write our final answer, which will be 4 multiplied by that 2 multiplied by x plus 5 squared, and then I simplify that 8 onto x plus 5 squared. And you'll notice the denominator has disappeared. That's fine. Sometimes that happens, sometimes it doesn't. So let's do some practicing. Alright, number 1. Back to my original pen. First things first, rewrite it as elementary school division with that dividing sign in the middle. So I've got my x plus 2, that's my numerator. I'll replace that main fraction bar with a division sign, and then I'm going to write my Original denominator as a second fraction. Okay. Do not touch the first fraction. Flip the second fraction. I'm just going to use brackets this time instead of the X sign, because otherwise it gets confusing. And everything on the bottom, so many brackets. Everything on the bottom stays on the bottom, everything on the top goes on the top. Just looking at this, I see that there's nothing for the 2 to interact with, and there's nothing for the x minus 2 to interact with. And remembering that x plus 2 and x minus 2 are not the same thing. If x was the number 10, one would be 12, one would be 8. You can't cancel them or combine them. So those things will stay in my final answer. So I'm just going to write them down first. But I also have an x plus 2 to the power of 3 over an x plus 2, and that's to the power of 1 when you don't see a number. So my exponent laws say I'm going to do 3 minus 1, and I'm going to have x plus 2 squared on the top. So that's my final answer. Same thing. Division sign. Now careful, I'm going to look a little more closely at this. I've got a negative exponent. So either before you do that or as you're doing it, you're going to be like, okay, if it's 3 onto x plus 5 to the negative 1, my base is x plus 5. The 3 is separate, so that should be rewritten as 3 over x plus 5, just to make your life easier. Same thing. First fraction stays. Less. I'm going with less brackets this time. Second fraction flips. Fraction. There we go. And let's look at what we can do. I can cancel this with this. X plus 5, x plus 5. Those are the same. 9 over 3. 3 goes into 3 one time. 3 goes into 9 3 times. My final answer? 3. So that was an awesome one. Sometimes they're a little trickier. They're not what you want them to be. So if I look at this one, 2 over x plus 7, middle fraction bar, there's a negative. So I'm going to sort that out on the side here. So if it was 6 over x plus 7 to the negative 3, I need to flip that x plus 7 to make the negative 3 positive 3. That's going to change it to going to the numerator, and there we go. So what we're actually looking at here we're still going to treat this as fraction math. If you flip the second fraction, anything that is whole just has a denominator of 1. And square brackets. This time, same. And I got to flip that, so I'm going to have 1 over 6 onto x plus 7. So this time I'm not going to be canceling the x plus 7s. I'm kind of going to be combining them. Before I do that, I look to see if I can cancel anything, and I can work with the 2 and the 6. 2 goes into 2 one time, 2 goes into 6 3 times, and that's pretty much it. So top times top, I'm going to get 1. On the bottom, I'm going to have that 3, and I had a single x plus 7 here, and I have 3 here. Combining them, 3 plus 1, 4. So let's switch topics completely to lowest common denominator. Sometimes these are called least common denominators, but that just makes that sound like it's like a rare denominator. But I just want the lowest possible thing that everything goes into. When you do addition and subtraction of fractions, plain old fractions like 1/2 plus 2/3, you did this in elementary school, and you would find a common denominator, and then you could add the fraction. So same deal. we need to do that, but suddenly our denominators could be something like 2x onto x minus 1. They could be algebraic, so it's a little bit messier. And our numbers aren't always going to be as nice. So for the rest of this slideshow, we're going to talk about finding lowest common denominators, and I'm going to leave simplifying algebraic fractions to the next one in Algebra Basics 4. Alright, so when we looked at 1/2 plus 2/3 minus 3/4, you may remember that in order to do this, you need to find something that they all fit into, and you would say, oh, they could all be fractions over 12. And we'll harp on this again, whoops, because it's easy to see that 2, 3, and 4 go into 12, and they all have to fit in evenly. They have to fit in as integers. You can't be having, oh, it goes 2.5. We're not mixing decimals and all that. And then you would change this fraction. If you multiply 2 by 6 to make 12, you would multiply 1 by 6 to make 6. You would multiply 3 by 4 to make 12, so you multiply 2 by 4 to make 8. And then you multiply 4 by 3 to make the third 12, so you multiply 3 by 3 to make 9. And you end up with 5 over 12. We'll revisit. So what we need to be able to do is find these nasty lowest common denominators, because if I look at the denominators here, I've got 22, 36, and 6. And yes, at the end of the day, I could multiply 22 times 36 times 6 and make a denominator that they all fit into, but it's going to be perhaps larger than necessary. So here's a little trick if you want to find the lowest. At the end of the day, if you end up finding one that's higher and just remembering to reduce at the end, that's fine too. But you have to do the reducing. So we're going to break each number down into its prime factors. And what I want you to do there is think about how you make things. Like, what's 22? How do you get 22? Well, there's only one way. You can multiply 2 by 11. 2 times 11 is 22. 2 doesn't break down, it's prime. 11 is prime, so that is the prime factorization of 22. 2 times 11. Looking at 36, and it doesn't matter if you choose 9 times 4, or if you choose 6 times 6, or whatever. It'll always work out. Or 12 times 3, it'll all work out. So I'm going to go with 6 times 6, because I'm lazy. And 6 and 6 are not prime, so we're just going to break them down. I can make 6 by doing 2 times 3. And I can make 6 by doing 2 times 3. 2 and 3 are both prime. I'm done. So I'll just change the order a bit. And you're just going to check. You can always go 2 times 2 times 3 times 3. Better get 36. And for 6, we know it's 2 and 3 just because we saw it in the 36 one. So that's our first step. Next, we're going to, and this is a list I had before, find each unique prime factor. So what different things do you see in there? I see 2's, I see 3's, and I see 11's, and that's all I see. So 2, 3, and 11. And this wording is terrible, but what I mean by this is find where there are the most of them. So if I look in 22, I have 1, 2. But in 36, I have 2 2's. And in 6, I only have 1. So there's more 2's in 36. Likewise for 3, it is more frequent in 36. And 11 only is, in 22, it's only to the power of 1. So what you're going to do now is be like, oh hey, the highest power I see 2 to is to the power of 2. That was complicated. And the highest power I see 3 being raised to is also the power of 2. And the highest power I see 11 being raised to is simply the power of 1. And if you do the math with that, if you do 2 to the power of 2 times 3 to the power of 2 times 11, so essentially you're doing 4 times 9 times 11, you're going to find your LCD, which is 396. Alright, so we're going to practice that a bit by pretending that these numbers are the denominator. So pretend that something like this is happening. And we're just going to break them up. So let's start with 18. And you can use your factor trees, or you can do whatever you want. So I know that 18, I'll do it up here, is 2 times 9. And I know that 2 is prime, but 9 can break into 3 times 3. Now I've got 3 primes. So anywhere it dead ends in the factor tree is one of your factors. 18 is 2 times 3 times 3. 21 is easy. 3 times 7, both prime. 14 is easy. 2 times 7, both prime. And 4 is easy. 2 times 2. So what are my unique things? I have 2's, I have 3's, and I have 7's. Where are the most of them? In the number 4, I have the most 2's, 2 to the power of 2. In the number 18, I have the most 3's. 3 times 3, 3 to the power of 2. And I only ever get 1 7 in anything. So there's your LCD. 2 to the power of 2 times 3 to the power of 2 times 7. And that should give you 252. Same thing. 39 is only 3 times 13. 8 is the power of 2, 2 times 2 times 2. And 12 is 4 times 3, which is 2 times 2 times 3. Unique things, I've got 2's, I've got 3's, and I've got 13's. Where are there the most of them? Well, in 8 I've got 3 of them, 2 times 2 times 2. And I only ever have 1 3 and 1 13. So there's our math to get our LCD, and our lowest common denominator is 312. Alright, when you're looking for algebraic LCDs, it's the same idea. Okay, so you're going to deal with the numbers the way you did before. You see the number 4 and the number 6, another 4. And these are low numbers, so I don't really need to do the whole factorization thing. I know that they both go into 12. So I know that my lowest common denominator will have something that 4 and 6 both fit into, and that is 12. Now let's look at the A's and the B's, and these are the other things I have. I see that I have A and A squared. And for the B's I have B, B squared, and B cubed. So when you're going to pick a variable, and I don't care if it's a binomial or it's a nice variable like this, you always choose the one that has the highest power. Because B can fit in to B cubed, but B cubed doesn't go into B. A can fit into A squared, but it can't go the other way. So pick the highest power. And that makes our LCD 12a squared b3. And you're just going to check, can 4a squared b fit into that? Yep. Same amount of a's. 4 times 3 equals 12. And b will definitely fit into b cubed. Check with each one, and it should be fine. So we're going to do this math next slideshow, but for now we're just going to find the LCDs. So what do you see that's different? You see a number, and it's 2. And you see x's to the power 1 and the power of 2. And x plus 7 is something completely different. It doesn't have brackets around it, but that is a binomial. If x is 5, x plus 7 is 12. So if I want to make my LCD, what do I need for numbers? I need 2. Looking at the plane x's, what's the highest power? X squared, and then x plus 7. That's your LCD for this problem here. Second problem, B, didn't label these, and D, x and x plus 1. So a lot of the times I see people make the lowest common denominator x minus 1. They're like, oh, there's the x, I've got it in, it's already in both places. That is not right. X is different than x minus 1. So your lowest common denominator is actually both those things multiplied. Another common mistake, if you have x minus 1 and 2x minus 1, people are like, okay, I can just squirrel the 2 in there somehow. Nope, two different things. test them by making x the number 2. If they're not the same number when you do that, they're not the same. So here's our lowest common denominator for 3. And we're going to look at D. So for numbers, we have 3 and 15. So 3 goes into 15, so you don't have to go any higher. And we have binomials, and we have x minus 1. That will have to go in, because it's different than x plus 2. And neither of those binomials are raised to any power, so they'll just go into the power of 1. So my LCD for D, 15, x minus 1, x plus 2. Last slide. What would be the lowest common denominators if these were all denominators? So I see 3. 15, which is just 3 times 1, that's prime. 15 is 3 times 5. 27 is 3 times 3 times 3. And am I going to fit it yet? 20 is 2 times 2 times 5. 2s, 3s, and 5s. I max out my 2s in 20. 27 has 3 3s, and there's only ever 1 5. Multiply those 3 things together. Can't do this off the top of my head, but I wrote it down somewhere. Where did I write it down? There it is, 540. All right, looking at this one. You have an x squared, and you have an x minus 4, which is also different from an x plus 2. There's nothing common between these 3, so you are going to write the LCD as all 3 of those things. Looking at C, so this 3x is 3 times x. So we have numbers and they're 3 and 9. So for 3 and 9, they both go into 9. Now that x by itself is in play. And then you also have an x minus 6, different than an x. So our LCD is the 9, the plain old x, and the binomial x minus 6. Last one. For numbers, I see 2 here, and I see an 8 here. So 2 goes into 8, so I need to have at least 8. Looking around, I also see a plain old x. These often get left behind. And then I see x plus 7. And here to the power 1, that's smaller than x plus 7 to the power of 3, so you pick the highest power. There's your LCD. And we'll learn how to use those to make equivalent fractions and simplify algebraic expressions on the next slideshow.